Hey guys, welcome back to my channel. Today we're going to do an experiment. Please like and subscribe. Now, let's begin. Let's read the instructions and information. World's greatest test tube. Scientists use test tubes of all different sizes and shapes to collect and study really cool things. A test tube can hold a liquid like water. A test tube can use to collect a sample of water from a river. A chemist uses a test tube to study chemicals. Scientists put dirt, leaves, sticks, rocks, and even bugs in a test tube. But you should never put food in a test tube. A test tube might not be clean. So what makes these test tubes so great? Most test tubes are made out of glass. This test tube looks like it is made out of glass, these ones, but it's really plastic. These ones aren't. It does not break if you drop it, but there is something else special about this test tube. What are those grooves on top? It kind of looks like the top of a bottle. A plastic 2-liter soda bottle to be exact. The world's greatest test tube is really like a baby soda bottle. That's right. Your test tube is actually look just like a 2-liter soda bottle before it is blown up into a big bottle. To make a 2-liter soda bottle, the plastic test tube is placed into a mold and heated. Then very hot air is blown into the test tube. This makes the plastic stretch like a balloon and fills the inside of the mold. The test tube grows about 40 times of its original size. Yep. When the plastic cools, the mold opens and the bottle falls out. That's amazing! Each test tube contains a different set of experiments. Just empty the contents of each experiment and follow the instructions. Okay, let's open these tubes and do the experiments. Okay, let's start with this one. Touchable bubbles. We're gonna do touchable bubbles. In this touchable bubble tube, we have this and this. Let's read. Hydrophobic and hydrophilic. Molecules are often categorized as either hydrophobic, water-fearing, or hydrophilic, water-loving. Or, of course, the molecules don't really either love or fear water. They just have a tendency to mix well with water or not. The tendency to mix well with water or not is based on how well the atoms within the molecule share electrons. In molecules like oil, the atoms share the electrons pretty equal. Other kinds of molecules don't share electrons very well. Some parts of the molecule pull the electrons towards themselves, leaving the other parts of the molecule electron poor. Water is a very polar molecule, but oil is not, so they do not like to be around each other. They don't mix well, because oil does not like to be around water. We say that is hydrophobic. And how do your bubbles get so bubbly? Bubble magic. The secret ingredient is, drumroll please, soap. Soap is made out of molecules with both a hydrophobic region and a hydrophilic region. Unscrew the Tetra Bubbles bottle, remove the wand, and blow some bubbles. Wait a moment, the bubbles will just be like regular bubbles instantly, but they will toughen up in just a few seconds. Watch the bubbles to change the color slightly. Go ahead and catch one in your hand. Wow.
На руку подивись.
Look what we got. Okay guys, we're off to the next tube experiment. It's called Clayed Agoo. Ooh. In this tube we've got jelly crystals and instructions. First you need to separate your mixed jelly crystals. Many branches of the science deal with classifying and categorizing things. Right now you are a jelly crystallologist. Put 3 different crystal colors in 3 different plastic cups. Add water to each cup of crystals, at least as twice as much water as there are crystals. And then let them sit for a few hours or overnight. Here's what we got. Let's put them aside. Hey guys, it's 5 hours later and look what we got from the jelly crystal, which was last experiment. Next we're gonna do magic ink. For this experiment, we need this and a special extra, disappearing ink. So, we need magic ink piped, the Limitless paper. We also need a paper towel or tissue, soap, water, and vinegar or lemon juice. Other great science ideas. Limitless paper is paper which contains an indicator similar to fine protein. Scientists use limitless paper to figure out how acidic or basic a substance is. When you put a drop of liquid onto a limitless paper strip, the paper will turn a different color based on the pH of the liquid. If the liquid is acidic, the paper will turn red. If the liquid is basic, the paper will turn blue. If the liquid is neutral, like water, the paper won't change color at all. Careful, magic ink works because air turns the chemical in ink colorless, but it leaves the chemical behind. Look, it is basic. That's cool. Over here, we dropped a few drops of water. Let's try with vinegar. Into red. It changed into red. So we have blue and now we have red. Okay guys, so for the next one, we're gonna need to keep the vinegar, which was from last one, pipette, and we need the disappearing ink. And we also need our test tube. Pour a little magic ink into your baby soda bottle. Add acidic substance to the magic ink in the baby soda bottle. What happens? Let's see. Guys, the ink disappeared. Look, it's gone. Wow. That was an amazing experiment. Let's go on to the next one. Next experiment, we're gonna be doing Super Ball. We also need this. Ooh, this is cool. For our own make your own bouncing ball, we need our plastic Super Ball mold and Super Ball powder. Fill your bowl or glass with water and set it aside for a moment. Snap your Super Ball plastic mold so that it is shut. Open the bag of Super Ball powder and pour it into the Super Ball mold until the mold is full. Be careful to not breathe it in. You don't want a bouncy nose. As you pour the powder in, gently tap the plastic mold on the table surface to help the powder settle more evenly. Dip the plastic mold into water and hold it under about 2 minutes. Okay guys, while it's doing its magic underwater, I'm going to read. How does it work? You've already learned about polymerization with the Wonder Worm, but how does a bouncy ball work? What makes it bounce? The secret of the bounce. If you take a picture of your Super Ball at the moment it hit the ground, you could see that it looked pretty squashed. Your Super Ball works because it is made out of a polymer like rubber, which is very elastic. This means it springs back into its shape after it has been deformed or squashed or stretched. Where either you throw the ball or just drop it, a lot of energy is contained in the motion of the ball, enough so that when it hits the ground, it can push the molecules that make the ball out of the places they want to be. But the molecules don't want to be like that. They fight back. Now let's take it out. They still have to wait for a few minutes, so I'm gonna read more. In fact, they fight back so hard and pulling themselves back to the places they want to be that they push off the ground, and the ball goes flying boing into the air. Same to say that substances do have this elasticity. Other substances don't have much elasticity. Have you ever played with clay, or what would you happen if you made a ball out of clay and dropped it on the ground? The same amount of energy would pull the ball of clay into the squash shape, but without elasticity, the molecules would get pulled or pushed out of their original places and just stay there, flop on the ground. What other substances do you know that don't have elasticity? Okay guys, let's take the ball out. Wow, look at that. Look at it. Our last one is Wonder Worms. For this one, we're going to need worm goo and worm goo activator. That worm goo activator. Ooey gooey fun! We need 2 ounces of blue worm goo, the 6-gram worm activator powder pocket, and warm water. My worm was kind of broken, but you get it. We just dump the water. Feels rubbery. Funky shape of a worm though. I also got some extra worms. Okay guys, thanks for watching. I think it was like super excellent. It was like fun, cool experiments. Comment below and tell me what was your most favorite experiment, and tell me if you want me to try some other ones. Thanks for watching. Subscribe.